So hi friends, today we'll be discussing about one of the key topic, or let's say one of the important topic. Not, I mean, most people doesn't look into it, but we shall say into it. OLTP versus OLAP. What are these? So these are database workload patterns. If you don't understand them now, it's not a problem. We will be understanding it. Yeah. See. So yeah, nice. Let's keep it like that. So, generally, there are two types of workloads for databases. One is transactional transactions, generally daily transactions, whatever we will be doing, not money transactions like database transactions. Like if you do something in your app and that does reflect in the company's servers, company's database servers, those transactions. And one other thing is analytics, which are not performed by customers or users. It is performed by company's internal data scientist or some analyst. So yeah, so for both these use cases or for both these workload patterns, databases are optimized differently. So the databases used for this transactions are optimized based on online transaction processing. We call it OLTP, online transaction processing. And this online analytical processing. So if we see OLTP, so if we see OLTP, so we shall see an analogy. OLTP means what? Generally, when a customer buys an item or updates inventory or something, he records a sale. What happens? That gets reflected in the database. And this kind of event occurs like 1,000 to like million times a day based on the company scale. So for this thing, we'll be using OLTP, and because each operation should be very quick, so the database should be OLTP optimized. And if we see into OLAP, what happens? The company's internal employees, they want to analyze all the sales for the last month or either last year. So for that type of queries, mostly read queries will be there. For that type of queries, they need to do OLAP optimization. So if we see OLTP, what we have learned, optimized for OLTP based system. Wait, OLTP system optimized for multiple or concurrent small read or write. I am saying here small because in the online analytic or in the analytics we generally scan lots of data, not a small data. So this is small when compared to analytics queries. Example, placing orders, updating profiles. Now if we see OLAP, here the queries are not small, they are complex here. As we discussed earlier, optimized for complex analytical queries, right? And here data set is very large data set. So generally happens like for business, and report generate reports, etc. Now if we see differences, key differences, like let's do a table. This is let's say first thing will be aspect, other thing will be OLTP, OLAP. If we see aspect, let's say purpose, why do we use OLTP? It's simple, it's for day-to-day operations. Why do we use OLAP? Analysis and reporting. And here how will the queries look? Either the select query, let's say select query, will generally they will be very simple and we'll query them by the primary key or something. But if we see for OLAP, they have many complex aggregations. Generally for analytics, aggregation is very important. Data, if we see whatever the data it is there in the database or whatever they will be reading, that will be mostly current state. And in OLAP it will be historical data, let's say 2 years back or months back, something like that. And the operations will be doing in the OLTP optimized systems will be insert, update, yeah, you are right, delete. But if we see in OLAP, mostly we will be doing select only, like just scanning or reading. If we see users, concurrent users, multiple concurrent users, it should be optimized for that. What for this? Few employees or few analysts, let's say, from company, that's it. Response time, it should be in milliseconds. We are customers, we don't use it if it gives after a year the response. And generally this OLAP, the queries are large and it queries on large data set, so it usually takes seconds to minutes. And schema, if we see, it should be normal, it will be normalized generally. And more specifically, if we say third normalized form, we shall learn about this normalized forms later. And it will be denormalized here for faster aggregations, or like in that case, instead of doing multiple joins and like referring multiple tables, we generally try to reduce it to single table, something like that. Now we shall see OLTP characteristics. If you see OLTP characteristics, high concurrency, man, high multiple users, right? And asset compliance must be there because it is user side, not from the company side, right? The user queries are from. So, and schema is normalized. Yeah, these are all what we have discussed in the table itself, but yeah, once again we shall see. And this is the most important thing, that is row oriented storage. Row oriented storage, this is, if we store based on the row, the simple writes will be faster. So we said it right, but it is optimized for the smaller writes. So in that case, generally we prefer row oriented storage. Now if we see OLAP characteristics, Yeah, you are right. Come on. Yeah, so before that, we shall see examples for this also. Yeah, generally database optimize themselves before PostgreSQL. These are optimized for OLTP systems. MySQL, Oracle, mostly all the SQL DBs are for this, for transactional workloads. If we see OLTP characteristics, complex queries, this is one thing. Aggregations, window functions across billion rows. Right. And what else? Okay, if we see storage, columnar storage here. So generally we don't retrieve all the rows, like all the columns in the rows. So we only retrieve only some columns. So in that case, columnar storage will be very faster. If we use columnar storage, those queries will be faster and easy. Denormalized schema. We shall learn about this denormalization in later videos. And batch updates will be there. Batch processing will be there here. Like, let's say data loaded periodically. By some pipeline, like by some ETL pipeline. It's a not non-real time, NRT, not real time. So batch updates will be done like periodically. And if we see examples here, Snowflake is the best or something in this. Generally, OLTP is for you, it is given to users, and OLAP is something called warehouses. Their warehouses will be using this for BigQuery. Okay, BigQuery, Redshift, ClickHouse, etc. Now we have, these are all warehouses, right? Now let's see generally what a warehouse is like. In warehouses, generally we have OLTP databases itself, and yeah, ETL, extract, transform, load, data warehouse. All these things you can. Sorry. I was saying something else, right? So sorry. Oh, data warehouses. So generally, how data comes to data warehouse. So source systems, if we see source systems, which are filled by customers data, filled by customers itself, generally we can say. So generally filled by customers interactions first time. So these are stored in what? OLTP databases. So now what happens? Some pipeline will be there, extract, transform, load thing, pipeline will be there. Now what happens? From that pipeline, like we'll load the data into data warehouse. And yeah, you are right. This data warehouse is OLAP optimized. See here, this data is not filled by users. You are getting it. And after this, on this some analyst or something will be happening on this. So some like BI tools will be used, business intelligence tools will be used. Yeah, yeah, that's it. And yeah, key takeaways are what for this? Like OL for OLTP for transactions will be using for fast writes, asset properties and normalized schema. And what for OLAP? OLAP is for analytics, complex queries, columnar storage, denormalization. So generally most companies use both of them. OLTP for operations. Wait, let me write this. OLTP for operations and replicate it to OLAP for analytics. That's it. ETL pipeline. Yeah, the ETL pipeline moves them from OLTP to OLAP, and generally this is the thumb rule. Don't run analytics on production OLTP. OLTP system. What happens? It will kill the performance. I think you got the gist there. Let's say a query needs to find total sales by region for the past year. What system will be using? Historical data we are querying here. So generally we need to use OLAP only, and that is best. Which storage format is better for OLAP? Think of it. For online analytical processing, we'll be querying only some columns, not all at the time. So generally in that case, if you store data column by column, that will be easier, right? So column based storage, column oriented storage, right? Thank you.